Everyone is talking about artificial intelligence today, but the meaning of the term has never been precisely defined or agreed upon. And never has the term invoked more hype, extravagant claims, controversy, and downright confusion than we are seeing today. But we all have an intuitive notion about AI. It is thinking machines that would have the comprehension to understand what you tell them and the intelligence to do what you said. In the midst of this current controversy, New Sapiens has pioneered an entirely new approach that we believe puts that long-awaited goal in reach. We call this approach synthetic intelligence, in contrast to all the previous approaches, which we think should be characterized as imitation intelligence, the approach that has produced only narrow applications. This is part 2 of a 9-part series being developed to provide people with the background they need to understand our technology. Since it is new and unique, there are no external resources for research. The goal of AI is to endow computers with knowledge. There are 2 ways to proceed. You could create software that generates knowledge out of external raw data, that is starting with a blank slate, which is how the human mind is perceived to work. Or you could find an external way to create computable knowledge so that computers could already have a critical mass of knowledge at runtime, which software could build upon. Since the term AI was first coined in 1956 in the paper which called for a conference at Dartmouth to study artificial intelligence, the whole enterprise has proceeded down the first path. And here in the actual paper, the quotation, the study is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine could be made to simulate it. That is aptly more described as imitation intelligence, because its approach is to imitate the human mind as best we can understand that. But that's an incredibly difficult thing to do, because the human brain is very hard to reverse engineer. The focus, though, of trying to reverse engineer the brain and trying to generate knowledge from raw data forces one down the path of looking at intelligence as the information processing challenge, which would be the focus on the software itself. And that then brings you to the notion of looking at algorithms. And in fact, AI today in this approach, imitation AI, is really been characterized as a quote, as the quest to discover some master algorithm or algorithms. In fact, in the book, The Master Algorithm by Pedro Domínguez, which is said that Mark Cuban keeps by his bedside, that's exactly how all of AI is considered to be. A problem with the last 60 years, however, is that AI, again, people don't agree what it is. It isn't really a science. It lacks a unifying scientific theory. And so in the lack of that, the vacuum is AI researchers would keep trying things, keep trying to mimic this aspect of what they think may be an aspect of human intelligence, or that aspect, and to see what would happen. And sometimes interesting things have happened, and some at least narrow problems have been solved. But to this day, 6 years later, researchers don't agree about what intelligence is, what sentience is, what consciousness is, and what the extent, if any of these things need to be understood and somehow baked into the solution, and whether they are fundamental or not to the enterprise. So where does that leave things? The lack of science leads to random experimentation. For centuries, alchemists labored to change lead into gold. They understood materials to be composed of atoms, but they didn't know their number or their properties. All they could do is put things together and see what would happen. Today's imitation intelligence is today's alchemy. Sometimes the alchemist found some interesting results. They could heat up a red powder and create a silver metal, but sometimes the lab blew up. And I think today, it's not really an exaggeration to say that AI researchers have kind of blown up the lab. A little history. So AI has had waves periods of popularity and then periods of pessimism. The first really big wave is now termed symbolic AI, and it reached its zenith back in the mid-1980s. Everyone at those times was very excited by something called expert systems, which featured extensive if-then logic. And the thought is that, or the belief was, they were trying to mimic the human ability to do logic. And they thought that they could codify knowledge as a series of rules, if-then rules, and chain them together into chains of reasoning, such that they could put in the computer the same kind of decision-making that human experts do in particular domains. And they generated tremendous expectations and hype. Many startups raised millions of dollars, just like they are today, and the big tech companies established their own AI centers and invested billions in attempts to commercialize the technology. But it failed. It failed rather spectacularly to deliver on these expectations. Too many rules. And after the investment bubble burst, there was nothing new on the horizon that could rekindle excitement and a belief that the claims that had been made and the promises that had been made could in fact be achieved. And after that, throughout most of the 1990s, AI was very much out of favor. What's wrong? What went wrong? You could say that the failure of symbolic AI is a failure of epistemology. Symbolic AI was fundamentally based on the idea that knowledge could be represented. That is, individual assertions, which each one, like a datum, a fact, a single fact, could be represented by one if-then rule. And the core epistemological assumption then that knowledge is a symbolic representation of reality and that it is contained in language, because the symbols that they used were the same words that we use. That approach made no distinction between data, information, and knowledge, which are in fact very, very different things. And the approach also required that the data that you were reasoning about was embedded in the code itself, in those rules, which is a huge violation of good programming practices. And so it was impractical. The second wave, which we are in now, is generally called by experts the connectionist AI. It's at least as old as symbolic AI, but it requires vast data sets and supercomputers that did not exist until after the turn of the century. It's more or less known as machine learning today, although a better name would be data science. And it's been so popular and so much money has gone into it, and it's generated so much enthusiasm that machine learning, this technique, which is based on artificial neural networks, has become synonymous with the term AI. When you read most articles today in the media and other places, and you read AI, think machine learning or data science. So why is it called AI? Well, kind of by, it's a bit of a reach, but kind of by analogy, because the human brain has neurons and natural neurons. And so we're saying we're emulating the human brain with artificial neurons. And so the brain is intelligent. And so the software, we call it artificially intelligent, even if it doesn't act intelligent. It's also called, because AI has become a bucket term, that any technique that mimics what humans do in their minds, going back to the Dartmouth conference, is called AI. But there's a problem with this. It's a big problem. And calling it AI has created what we could call cognitive dissonance, a widespread phenomenon that has led to a rush of applications that are proving harmful. Cognitive dissonance occurs when you're told that X is one thing, but what you're told it is by experts doesn't match what you intuitively know it to be. And what we, as I said in the beginning, we know AI to be intuitively is machines that understand what we say and have intelligence to do what we tell them. And we don't see that in this software that we were given. But we say, well, we'll make excuses for it. There must be an intelligence in there, or we'll give it more credit than the results would warrant otherwise. And this has led to severe problems in AI today, or imitative intelligence, as we call it. Machine learning algorithms are fundamentally statistical, and so they're good for finding statistical patterns in large, otherwise uniform collections of data. But when you use algorithms, statistical algorithms, to make decisions that directly affect individual people's lives, you are treating people as statistics. And when was it okay to do that? And that has led to many, many very well-documented and very abusive practices. For instance, bias in getting people loans, getting into a university, or getting a job, because a machine learning algorithm said, statistically, this person isn't going to be well or do well. And often that is not the case, because individuals are unique and variable. And a person who doesn't fit on the bell curve of statistics is often the very kind of person you need, and the very kind of person who will excel. Now, the use of these algorithms to increase advertising revenue has led to device addiction and a documented rise in partisan behavior and extremism. This is serious damage. There's a quote here by Tim Kendall, former director of monetization at Facebook, now Meta. These algorithms are designed to feed people things that get them focused on different types of articles. And it feeds them, it recognizes their browsing patterns and their click patterns, and feeds them things that are going to cause them to make more clicks. And that generates more advertising revenue. But what gets people to click on more on stuff that they agree with and stuff that they really disagree with. So again, the radicalization and partisanship. This is a very serious and well-documented problem of the rush to consider machine learning algorithms AI in the first place. Now, there's nothing going on there in the history of AI that has generated more excitement as well as controversy and downright fear as chatbots. And chatbots actually have a long history. In 1964, Joseph Weizenbaum at MIT AI lab created one called ELIZA, and it was based on a simple pattern matching and substitution methodology. But it mimicked the dialogue between a psychotherapist and a patient. And it was so compelling because it really did give that illusion of a conversation that some people fooled into believing that ELIZA had knowledge and understanding. Sounds familiar. Even then, it was compelling enough that there's a very famous story that one day Weizenbaum came into his lab and his secretary was on the computer talking to ELIZA, seemingly to talk to ELIZA. And she said, "Doctor, could you please leave the room? I'm having a private conversation with ELIZA." And at that moment, he realized that she was taken in by the illusion that ELIZA was really talking to her about her personal life. And when he told her, "It doesn't understand a word you say, and oh, by the way, I have access to all these transcripts," both were mortally embarrassed. And he went off and destroyed the program. Today, that phenomenon of people being taken in by the illusion of intelligence is called the ELIZA effect. And today, in the guise of ChatGPT and its many clones, the ELIZA effect is rampant. Now, already these chatbots, some of them more benign than others, like the digital personal assistants like Siri or Alexa, or the ones you see on websites, or even the social chatbots that are a little bit more controversial. And no one makes many claims that, and no one is very at all taken in by the illusion they provide because it's not very compelling. But ChatGPT and the other large language models are extremely compelling. Their illusion of comprehension, the illusion that they actually understand the text that they're generating is so powerful, people can hardly believe that they don't understand. In fact, it takes an expert. And it takes an expert to read what they put out and be able to find the subtle errors and the misconceptions or the downright misinformation that's mixed in with stuff that is experts, which also makes them so really so pernicious and dangerous. Here are some examples of that, of the danger of these systems because they are so compelling. Gary Marcus, an AI scientist and entrepreneur, it points out that these things make it possible to generate huge quantities of misinformation to further partisan objectives or other types of misinformation or motivations which are not beneficial to society. Other dangers, they can generate things. A recent one on this panel on the right, Christian Green, asked a chatbot, large language model called Galactica, to do all kinds of things that it went right on and did. For instance, a research paper on the benefits of eating crushed glass. And you read these things, and because they're in the form of a scientific paper and the language and syntax is so flawless, it's hard to believe that you're not reading the output of an expert and a scientist. And that is so dangerous because scientific papers and the way they're written and the way they cite their sources and their research, it's all in these artificially generated text. So this is the information we rely on from scientists. And now you have something that comes out and can be made to sound exactly like a scientist without there being a shred of science in it. Another problem with imitative AI is that it does today and has always required massive resources. For instance, both in the development side and in the operations side and the training, and then to operate the program once it's up and running. Development-wise, for instance, Siri started out as a DARPA program. It cost the U.S. government $200 million that we paid for before it was spun off as a commercial product. Apple's been pouring more millions into it for 12 years or so now. Amazon Alexa had until very recently 10,000 people working on it. Why? What were they all doing? They were in back rooms trying to figure out if somebody types in the following words, can we recognize that, and can we write some code that will capture those words as keywords and figure out what to do with it? It's hard. It's very hard to try to actually get something from people when you don't understand the meaning of words. Keep in mind that the ChatGPT and others don't really learn from you, and they don't understand what you're saying. They just take some words that you give them and they generate words. Sometimes it works as a question and answer. Sometimes it doesn't. Another example of this lack of scalability, particularly in the large language models, is the amount of energy they consume in training, or just the amount of computational power they require. A startup called Hugging Face is building one of these large language models, and they bragged about how efficient it was compared to others, in that to train it, the computer power it consumed in the training process only generated and released 25 metric tons of carbon into the atmosphere. So imitative AI, large language models especially, have been coming under fire for not being a sustainable technology, as well as there are other serious problems. Now, one of the things we hear is that, well, these things have problems, but they're going to get better in the next version. Always, they're going to get better. They have problems, but they're going to get better. So GPT-3 had 100 times more training parameters than GPT-2. GPT 3.5, which is what ChatGPT was based on, had 100 times more than that. It cost $3 billion to develop, by the way. And GPT-4 is believed to have 500 times more parameters than GPT-3 did. That's 100 trillion parameters. And they say it's somewhat better, but it's not 500 times better. The problem is these things have diminishing returns. The more they require more and more data, but they don't return twice as much data, it doesn't give you twice as much performance. And so they're already up at the flat part of a curve like this, proceeding asymptotically toward a level of performance that they may never reach. A good example of that is the Tesla self-driving cars. They got to really a good level, about 85% of where they needed to go pretty quickly. Then they added 10 times the computing power, 10 times the data, did it all again, and they went from 86 to just a little bit further. They didn't go that much farther. Already they're on the flat part of the curve. And this has led to commercial disappointments. Even while everybody rushes to invest in GPT, chatbots have not delivered in the past. Amazon was supposed to make money off of Alexa, and last year it lost $10 billion. Colossal failure, it's been described as. Why? Because it was supposed to generate lots of revenues where people would talk to Alexa and tell it to order stuff for them on Amazon. And the problem is it never got enough language comprehension that people felt comfortable to do that. People like it to turn on the lights, and they like it to set timers or to play a track on Spotify. It's good at that. But they don't trust it to order stuff because they can't really describe what they're looking for. It doesn't have enough language comprehension to ever get it right. So a colossal failure. So I want to talk about some of the myths that are being out there about imitation AI. And it's particularly today. The big tech companies are all behind this. And they all are giving us a narrative that many, many people are buying, including investors, and including the general public, and including the media. The first myth is that if the illusion is good enough, it's as good as the same thing. So if you have the illusion of being that if you ask a question of a chatbot and it gives you the right answer, even though it doesn't actually, and you understand it doesn't actually understand the words in the question, it doesn't understand the words in the answer as a human does, knowing what the words means and having some knowledge about that to say, yes, that's what this means and that's what that means. But if it's the right answer, that's good enough. Well, that's fine if you're playing a game of Jeopardy, I guess. Although I don't really think it's fine in Jeopardy because it's not really playing Jeopardy in the same way. Jeopardy is a test of human knowledge and memory when a human plays it. When a chatbot plays it, it's an entirely different thing. So there's some utility in question answering, but in the end, when you get to the extremes and when you get to subtleties and when you get to things which aren't just a matter of reciting facts and answers, it gets very, very problematically, very, very fast. Now, the Turing test, which was based on if you can't tell the difference between an AI and a human in a conversation, what difference does it make, is often used as a justification. But in fact, in the real world, an illusion and reality are not the same things. A rhinestone is an attractive illusion of a diamond, but you can't use one in a drill bit. You can try, and you can, maybe it might look okay at first, but it won't last long and it will cause real problems. Another is that the problems in the current applications are just temporary and will disappear in future versions with bigger training databases. And that you hear all the day, especially right now, when there's all this furor about ChatGPT and the other large language models, and people are putting out their obvious dangers and their obvious problems, and we're hearing again and again, we'll get it better, we'll get it better. And people criticize, well, these chatbots are still making things up. And the experts say, yeah, they are still making things up, but it will get better. It won't. They will always make things up because the statistical amalgamation of words based on what other people have said at other times and places can never be guaranteed to actually deliver truth and meaning and validity. You can't. It's fundamentally impossible. So the bigger models, again, especially since we're already in the flat part of the curve, they're not ever going to overcome their inherent difficulties. Jan LeCun, the father of machine learning, a machine learning pioneer, recognizes that these large language models are not on the path to true AI. Number three, machine learning applications already have human-level performance. An egregious example of that is GPT-4 is said to score 99% on a law board examination, which is a multiple choice Q and answer standardized test. And so the implication is that's human-level performance. Human-level performance on what? That's again like human-level performance on Jeopardy, but it's not doing the same thing. And people shamelessly, I think, let people, and I've heard journalists say that, oh, well, I guess ChatGPT is ready to be our lawyer. Being able to regurgitate this answer to this question when you just look at them as patterns of numbers that match, doesn't mean you know anything about law. Doesn't mean you have an expertise is a body of knowledge, which is a hard-fought model of integrated ideas that support one another. There's nothing like that going on with chatbots. So they don't have human level performance. Another example of that, someone we just said from OpenAI, one of the companies that make these chatbots, that some of the text generation, these things are generating text with human level performance. Well, it's not an interesting turn of language. Generate text. Do you generate text? No, you write, you speak, you comprehend. You don't generate text. It's a different process. When human beings use language, they are communicating. They're taking an idea in their mind and they're transferring it to another mind through the encoding process of language. That's not what these chatbots are doing, because they're not starting with any ideas. They're generating texts statistically based on text you give them. You seed them, they take the seed, they statistically generate text. That's not communication. Machine learning, as I said, is a point on the path to true AI. There's no evidence whatsoever. They have no more comprehension today than they did with Eliza. They don't understand what you say. They have no knowledge of the world. They have no comprehension of the world. And for all the billions that have gone on to them, they haven't taken us any closer. In fact, you can say that to the entire enterprise of imitative AI. It's created some software that can solve some narrow problems, but it's strictly gratuitous to call them AI in the first place. Why is that done? They call everything AI because AI is exciting. AI is sexy. AI is supposed to bring changes to the world. It's supposed to produce AIs and robots that do all the things that are difficult and dangerous for us to do. Everybody wants to wrap themselves in that mantle. But it's looking more and more like a scam. And we're seeing it today as a scam. These companies, the big tech companies particularly, and their partners like OpenAI, which is really completely funded by big tech companies, have kind of sold us a bill of goods. But it's worked out well for them because it's attracted huge investments into these companies. And by claiming breakthroughs in AI, they can cause huge increases in their market cap. So, of course, that's dangerous. Google's market cap plummeted by 12 billion in one day when it introduced its large language model, BARD AI, which had misinformation even in its first demo. A week later, Microsoft valuation lost $6 billion when its ChatGPT demo was also found to output misinformation. However, churning and burning, the money is still pouring in. And, there's an unsavory back channel about that. When all these companies, these small companies, venture-funded companies, which billions of dollars is flowing into, when they go out and build their chatbots and their large language models, where are they getting the computers to do this? They're getting from Google, they're getting from Microsoft, they're getting from Amazon. So the big tech companies can't lose by this AI investment bubble until it bursts. But in the meantime, the first waves of investors will still have reaped huge amounts of money. So the big tech companies in imitation AI have found a great thing which they can pump their valuations and their stock value. And we've seen what happens in the end with that. We see the bubble burst. And a lot of people lose money, but not the early ones. Only the ones who are, standing when the music is over and haven't gotten a chair. This happened before with symbolic intelligence back in the 1980s. And when that happened, and when the investors who were still standing when the music was over looked around and said, "Well, what happened?" They looked about and said, "Well, is there something else that is going to actually give us what we were promised here? Is there a new technology on the horizon that can do what we were told this kind of AI could do?" But there wasn't. And that's why AI fell into disrepute for more than a decade. But this time there is. There is a technology out there that will disrupt imitation AI and the chatbots. and it is already here, and that is synthetic intelligence. In our next session, we will talk about real AI from first principles, not imitative AI, but the real thing. And we will start to lay a foundation for a science of AI. We'll talk about what is the goal? Why do we want to do this? What is the benefit and allure of it? And let's get precise about all these words people were throwing around. What is the difference between intelligence and knowledge? What is the difference between data, information, and knowledge? What is the difference between language and knowledge? And what is the difference between models and symbols? All of these things are fundamental to the science of AI. Thank you.